Sorry the video cut off before. So just to kind of wrap up, you're going to talk a little bit more in a separate part of a lesson about limits at infinity and what those look like. And there's going to be a lot more to talk about that beyond this particular class and this particular chapter. So just really focus on the fact that you need to think about the fact that if a number doesn't exist, then that limit also doesn't exist. Okay, so I wanted to do, kind of one more problem with you guys, and then you've got some that you can practice on your own. Okay, so same sort of thing as before. I'd like you to at least take some time and graph this example, okay, example number 1, and then I'll talk about what the different answers to these parts of the problem are, okay, and kind of review this notation a little bit for you. Okay, so see you back here in a minute once you have taken the time to graph these two functions. I should also point out that you can totally use like a graphing calculator, Desmos, whatever. There's all kinds of ways to acquire the points that you need in order to create this picture. So whatever tool you want to use to help you with that, go ahead. Hey folks, all right, so this may have taken you a little bit longer than expected because this graph has some really huge values. Okay, so a couple of things. I went by 2s and that wasn't even quite enough. I maybe should have gone by like 3 or something on my scale. But anyway, the real meat of this part is just to talk about the fact that, if there's a little symbol in that superscript, that's going to indicate just a single-sided limit, whereas if there's nothing there, that's talking about a limit in its entirety. So if you look at -2, which is kind of the key point here because it's where our function shifts. The first function that I've labeled kind of in blue, it approaches 15, okay? And so does the right-hand limit, which means that the limit in general at -2 does exist. And by the way, I want to point out that this is a closed dot because the second function has the same value of 15 and overlaps, so it ends up closing up what would have been an otherwise open point. Okay, so if you have a solid, so if you have like a open and a closed dot, and if they end up being in the same place, imagine just the closed dot covering up the open one and kind of trumping that value. Okay, if I take a look at two other things, the value at -3. So if I go to look at my function, I notice, I didn't actually put a point there. So that might mean that I need to figure out what f of -3 is based off of this equation. Now, just to save myself a little bit of time, I'm going to show you that I put these equations into Desmos, and so I got 28 for that limit, okay? Which makes sense. It should definitely be higher than 15, some sort of value larger than 20, just based on my graph. And then the limit at -1, same sort of situation. I'm going to look at my equation, and it looks like that one was a little bit higher than 20. I think that point that I was graphing was 21. And just to double check, I'm going to look at my other equation, and yeah, at -1, it had a height of 21. Okay, so hopefully that helps you a little bit more just with that one additional example. And have a great rest of your day. Thanks so much for listening. All right, see you back here soon. Bye.